Oh, hi, and welcome to video number 169. This video is on the volume of Frustums. And the keyword here is frustum. You don't have to say it a silly way like I did. Frustum and similar. Now, frustum is the bit of a cone that you get left over when you chop off the top of a cone, right? And a similar object is one that is the same object, but it's a different size. Has different dimensions. Okay, now the method states to calculate the volume of a frustum you need to know the formula for the volume of a cone, which will be given to you. This could be a topic that is only on higher papers. I don't recall ever seeing a question on frustums on a foundation paper, but technically on the specification it could be a foundation topic, but it would be very top end. Now the big cone and the little cone are similar. Okay, they are similar objects because the little cone is part of the big cone, right? Basically, you chop off part of the cone and you end up with another cone there, right? And the bit that's left over, like I said, that's the frustum. Okay, now what you got to do is find the volume of the big cone, find the volume of the small cone, the bit that's removed, and then take the volume of the small cone away from the volume of the big cone, right? Then you will have the volume of the frustum. You may need to rearrange to find other things or use other bits of math to find other things as well, as always. So, question number 1 asks us to calculate the volume of the frustum. So let's just follow the steps, follow the method, and it will work it out, okay? So we've got all the information we need. We've got the dimensions here. We've got the radius, and we've got the height, the perpendicular height. H is the straight up height for the volume of the big cone. So I'm going to put volume of big cone equals 1/3 of pi multiplied by, I'll just put multiplied in there, multiplied by the radius squared, which is 3 squared, and then multiply that by 12. Okay, and then the volume of the small cone equals 1/3 multiplied by pi multiplied by 1.5 squared multiplied by 6. Okay, now let's get our calculator in to do those calculations. So big cone. Has a volume of 36 pi. And that is in centimeters cubed. And the small one, we can just go in to the thing that we did there, what we've already done. Just delete the 12, put a 6 in, delete the 3, and put a 1.5 in. 9/2 pi centimeters cubed, right? So the volume of the frustum equals 36 pi minus 9/2 of pi. And that's in centimeters cubed. Right, so 36 shift pi minus that answer equals 63/2 pi 98.96. Let's round it. If we had to round it to decimal places, let's do that for this one. Let's round it to 2 decimal places. 98.96. 98.96 centimeters cubed. All right, and I'll just show you what I mean if you've not grasped it yet. This whole shape here, all right, is that's the volume of the frustum, the bit that I've shaded in. Okay, that top cone has disappeared. The bit that's left over, the volume of that bit is this answer here. Okay, right, let's have a little look at the second question then. Question number 2 is a bit more contextual. We are going to need to use that again. I didn't put it in all of the problems because it's there on the page in front of us. All right, you always get given that, or you will always get given that. So a paper cone is filled up with water. Calculate the volume of the empty space inside the cone. Now the empty space inside the cone happens to be, if we think about the big cone and the small cone, right, this empty space happens to be a frustum. Okay, So we can work out the volume of the frustum here. So the volume of the big cone, I'm just going to put volume of big, VBC, volume of big cone, equals 1/3 multiplied by pi, multiplied by the radius, so that's 2 squared, multiplied by the height, which is 18, and then the volume of the small cone is equal to the same thing but with different numbers in it. 1/3 multiplied by pi multiplied by 1.5 squared multiplied by oh, we haven't got the height. Okay, that's what I was going to say. This is going to be pretty much exactly the same problem. All right, we haven't got that height. We need to find that height. Okay, almost missed that. Now we can't find that height because I did mention earlier that this cone here is similar to this cone here, the big one. Right, small one is similar to the big one because it's part of the big one. So the way that we're going to find that is we're going to work out the scale factor here. Okay, the linear scale factor between these, or the length scale factor between these two numbers. So I'm going to do the 2 and I'm going to divide it by 1.5, and that's how many times bigger it is. 1 and 1/3 bigger, okay, or 4/3 the size. So if I take the 18 and divide that by the answer, I'm going to get the height of the cone there. That is 13.5 centimeters. Okay, and I haven't written any of that down, so I will write that down, and I'll write it down here. I probably should have done that before anything else, right? But it doesn't matter when you do it. So the thing that I did is I did the 2 divided by the 1.5, and I got 4/3. Right, I then did 18 divided by the 4/3 because I want to find the height of this, and there is a video on doing this particular skill, and that gave me the answer of, I can't remember what it was now, 13.5. Oh yeah, because I wrote it down there, 13.5. All right, so that is the height of that particular cone, right, which kind of makes sense, doesn't it? Now we can use that, so 13.5 goes in there. Right, now we've got all that, we're just working out the volume of the frustum, if we've got the formula sorted. So, oh, I have to press the fraction button first. Apologies, this bit does take a little while, doesn't it? Alright, just hum to yourself whilst I'm typing this in. I won't do it on here, just in case you dislike the tune. Alright, 24 pi centimeters cubed for the volume of the big one. And the small one we can do a little bit quicker because we can just delete that, put that in, and then we can delete that, put that in. There we go. 81/8 of pi centimeters cubed. Keep it in terms of pi, no point faffing about there because we haven't finished things off yet. So the volume of the frustum equals, which is the empty space inside the cone, remember, the 24 pi pressed it, minus the answer, not the answer, just minus the answer. So 111/8 of pi centimeters cubed, and we can give our answer in centimeters cubed. But let's round it off to a decimal. So let's say 43.6 centimeters cubed. Fairly decent degree of accuracy. One decimal place will do. That's fine. All right, that's the end of that problem. That's the space inside the cone that can still be used to fill with liquid or whatever. Yeah, it's water. Right. Okay, let's look at the third and final question on this slide of problems. Now, this one asks us to find the perpendicular height of the frustum. Okay, so this length here. What we can see is that the whole length through the big cone, right, is 20. We just don't know what here to here is because we haven't got this length here. All right, don't know what that is. But the good news is we can use something to work it out. All right, we do need that, right? So we can then work out the linear scale factor between these two cones. Right, and then work out what this perpendicular height of the frustum is. So from here to here. All right. So the thing that we can use, because we've got the slant height of the cone is Pythagoras. All right, we can use Pythagoras' theorem. This length is our 20 centimeters, and then we've got a right angle there at the bottom. Okay, and then we've got this slant height of 25 centimeters. So there's my right angle. Okay, so the hypotenuse, and we'll do Pythagoras later, video on its own, or in its own right, but this is a nice example of where we're using Pythagoras to work other things out. If we want this side here, we want to call this one C, because C is always the longest side. This one could be B and this one could be A, right? We're going to do C squared, or in fact I'm going to do it the quick way in this video. C is equal to the square root of, and I'll explain this in more detail later, all right? But C is equal to the square root of, A is equal to square root of C squared minus B squared. Okay, so therefore A is equal to the square root of 25 squared minus 20 squared. A equals, right? There's our quick way of doing that. Like I said, I'll explain it in more detail in Pythagoras video, just to hook you in and make you watch the Pythagoras video. I'm sure it's going to do that. 25 squared minus 20 squared equals 15. So A is 15 centimeters. All right, which is a nice whole number. Now what we can do here is work out what the linear scale factor is, or the length scale factor. Linear scale factor equals 15 divided by 6. Okay, so 15 divided by 6 is 5 over 2, 2.5. Right, so this length here is 2.5 times bigger than this length here, which means that this length here is going to be 2.5 times bigger than this length here. Okay, so let's work out what that length is. All right, the little cone's perpendicular height, and we'll take the 20 and we'll divide it by 2.5 because the big one is similar to the little one. All right, so 20 divided by 2.5. It keeps putting answer. 8. So 8 centimeters is the little cone perpendicular height. Okay, that's not our answer because we want the perpendicular height of the frustum. So if that bit's 8 centimeters here to here, right, and this whole length is 20 centimeters, 20 take away 8 equals 12. Okay, so 12 centimeters is our final answer for that particular problem, right? And it's recognizing that you have to use Pythagoras there. Very, very tricky problem. Probably would be pretty harsh to get on a foundation paper, but although is technically still all just foundation maths. All right, so I hope you've enlightened yourself by watching that video. I hope you like the video. I hope you subscribe to the channel if you haven't yet already done so. I hope you are going to click the link and do some more practice on this particular skill. And I hope you're enjoying yourself and having a lovely day. Thank you so much for watching. Take care of yourselves. Bye bye.